Here in this problem, we are analyzing the graph of a rational function. So you're given a rational function r of x equals x squared minus plus 4x minus 12 over x plus 1 times x minus 3 times x plus 6 in the denominator. Now one thing it says is because I have to factor the numerator and denominator as the first step. The denominator is already factored, so I don't have to do anything with the denominator, but the numerator I need to factor it. So I'm going to write r of x equals, the factors on the numerator are x plus 6 and x minus 2 multiplied to be negative 12 added to be 4. In the denominator I have an x plus 1 times x minus 3 times x plus 6. So I see a common factor in the numerator and denominator of x plus 6. So this is telling me that at x is equal to negative 6, there is a hole in the graph. Okay, I'll revisit this at the end when I'm graphing it. So, but this is an important information that I need to remember. So let me highlight that. When I look at the graph at the end, we will just we will look for what the y value is at x equals negative 6. Okay. Okay, so the next step here is to find the x-intercept. So now my simplified rational function is r of x is x minus 2 over x plus 1 times x minus 3. An easy way to look at this is, this is of the form p over q, right? So P gives me the x-intercept and Q gives me the vertical asymptote. So here I say x minus 2 equal to 0. Therefore x equals 2 is my x-intercept. So 2 comma 0 is my x-intercept, and x plus 1 times x minus 3 equal to 0. So therefore x plus 1 equals 0, x equals negative 1, x minus 3 equal to 0, x equals 3. These are my vertical asymptotes. So I have my vertical asymptotes and my x-intercept. So let me fill in my columns here. So 2 comma 0 is my x-intercept. Vertical asymptotes must be written as an equation. So I'll write x equals negative 1 comma x is equal to 3. Okay. So in the next part is going to find the y-intercept. So to find the y-intercept, I'm going to plug in 0 for x, so which is r of 0 is what I'm looking for. 0 minus 2 over 0 plus 1 times 0 minus 3. And again, I'm using the simplified rational function. So r of 0 is equal to negative 2 over negative 3, or r of 0 is 2/3. So my x is 0, y is 2/3, gives me my y-intercept. So going back to my problem, x0, y 2/3 is my y-intercept. Okay. So now the next step is to find the horizontal asymptote. Like if you look at the polynomial, which is r of x is equal to x minus 2 over x plus 1 times x minus 3. The degree of the numerator is 1 and the degree of the denominator is 2. So if I go x times x, right, the first term will be x squared. So degree is 2. Since my numerator degree is less than the denominator degree, so this is my condition for to have the asymptotes. Since my numerator degree is less than the denominator degree, where it says n is less than m, then the graph has a horizontal asymptote, and the horizontal asymptote is y equals 0. So for this problem, this has a horizontal asymptote, and then that is y equals 0. So we already know if it has a horizontal asymptote, then there is no oblique asymptote. So I don't even have to look for oblique asymptotes. Okay, so there's no the horizontal asymptote is y equals 0. So you go y is equal to 0 is my horizontal asymptote. Okay, with this information that I found till here, I need to look at the graph of the function. So you know, with all this informations that I have, let me go to the graph that I have in here and see which one would match. Or you know, you can just graph this and look from there, but first we will analyze it and then go. Okay, so then I'll use the calculator to show it. Okay, one of the first thing I see is the x-intercept 2 comma 0. So x is 2 comma 0. Okay, so I have this looks like it's going through 2. This looks like it's going through 2. That looks like going through 2, and this also looks like going through 2. So that's not going to help me much. So the next one I see is the vertical asymptotes at -1, x equals -1, and x equals 3. So x is equal to -1, x is equal to 3, -1, 3, -1. So this cannot be the graph. Here it's 6. So this option is gone. Because here, so see that itself is at 6, right? So, but it has to be at 3. So I say that cannot be the graph. Again, this cannot be the graph too. So it has to be one of these two. Okay. Now the next option is horizontal asymptote at y equals 0. Both cases are fine. So the next third one I'm looking at, the next option is the y-intercept. So y-intercept is 2/3, which is less than a 1. So if I look at this graph, this has a negative y-intercept, so that cannot be the graph. So this has to be the graph, or this has to be the answer. But we'll verify it. This should be the answer. So to do that, what I'm going to do is, one thing that I see at -6, you see there is a hole in the graph here. There's a hole in the graph at -6, so that's correct. So to cross check it, I'm going to use my calculator, and I'm going to graph the simplified version. So parentheses x minus 2 divided by open big parentheses and then a smaller one, because I'm not going to FOIL the denominator. I'm keeping it in factored form. I can if I want to, but I don't want to do additional work. So x minus 3, I'm closing double parentheses and keep my window at standard, and I will graph. Okay, so look at the graph in the calculator and look at the graph that I have here. They look exactly the same. Now one thing is, it didn't show me the hole in the graph because here I'm drawing a continuous function. I already, when I inputted the function at y equals, I did not put the hole in here, but I need to remember that there is a hole in the graph here at -5, because initially when I started with, I cancelled this x plus 6. So since you cancel the x plus 6 at the beginning, you have to remember to put a hole in the graph. Okay? Okay. So from here there's two more things to go. Like I need to find the domain and the range. Here it is. Okay. To find the domain and the range. So either I can use my graph that I finalized to look for it. Domain is all possible x values. So by looking at the graph, I can say the graph goes from -infinity to all the way to -5, and sorry, -6, not -5, -6, because that's where the hole is. Okay, then there is a break there. So from -6 all the way to the first vertical asymptote, which is -1. Then again it's taking from -1 to the next vertical asymptote, which is 3, and then union 3 comma infinity. So how I'm looking at this is here, to find the domain, all the way from -infinity up to that point, not including this point. So -infinity to -6, because that's where my hole is. So this is my -6. And then union from -6 all the way up to this point here, because this is my -1, where there is a vertical asymptote. Then union from -1 to 3, where there is my vertical asymptote, then union 3 comma infinity. So that's my domain. And my range is, since the graph goes on top, like in the y-axis on everyone, the range is going to be from -infinity to infinity. Okay, I hope this is clear.